You guys have done a good job so far with volume, finding volume of a cylinder, whether you know the radius or the diameter, and then just using word problems that involve the volume of a cylinder. The next thing we're going to talk about is composite solids. So what do we mean by composite solid? Well, it's a shape that's made up of many other objects, okay? So this would be an example of a composite solid. So as you can see, we have three kind of different shapes. We have a cone, okay, cylinder, and then down here would be a rectangular prism. Now, how do we find the volume of a composite solid? Well, objects made up of more than one type of solid are called composite solids. So we need to decompose the figure and find the volume of the individual solid. So what this is saying is, hey, let's take this apart. Let's put the cone here. Let's put the cylinder here. And we need to find the volumes of all three of these. So if I find the volume of a cone, cylinder, and a rectangular prism, and then I can just add those together. So that is how I can find the volume of a composite solid. So you're not always going to be able to drag them apart like on a smart board, but in your head you've got to try and separate these images. So what's this next problem about a composite solid? Well, this one's actually a little interesting because it's not necessarily two shapes put together. It's a rectangular prism with a hole in the middle of it, right? So I can't just find the volume of the rectangular prism because that wouldn't be accurate. I've got to find the volume of the rectangular prism, and then I've got to subtract this cylinder in the middle. All right? So how are we going to do that? Well, remember what the advice was. We've got to decompose the figures. So basically, I know that I've got to find the volume of the rectangular prism first, and that I've also got to find the volume of a cylinder. So let's do those two things. Okay? Well, to find the volume of a rectangular prism, you guys should be experts at that. Okay? We know that it's going to be, actually, it's not just a rectangular prism, my mistake. It's actually a cube, all right? And what we know about a cube is all the sides are the same. So this is 12, and this is 12, and also we know the height is 12. So when we do base times height, or length times width times height, I've got 12 times 12 times 12. And so the volume of the rectangular prism is going to be 1,728. All right, so there's my first one. All right, so this is our cube. Now what about the cylinder? Well, we know that we're going to do pi r squared h. Well, what is h? H is 12. I already know pi is 3.14. What's my radius? Well, they give us the diameter of 2, so I know that my radius equals 1. So that's going to be 1 squared. And if I multiply those together, I get 37.7. Now, if this was a cylinder stacked on top of a cube, we could just add these two together. But since this is a cube with a cylinder hole in it, we have to subtract. And so I simply do 1,728 minus 37.7. And I end up with 1,690.3. And we're doing millimeters, so it's millimeters, and volume is always cubed. So once again, just remember, when we're doing composite solids, you want to decompose the figures. So break it down. What are the figures you're using? And find the individual volumes of the solids. Okay, go ahead and try this. Got it. Just as a hint, you have a rectangular prism and what looks like half of a cylinder. So think, I've got to find the volume of the cylinder, and then I would need to cut that in half. Go ahead and try that one.